All right. So here we are talking, I'm giving you an update on the activity of the Xen Project GitLab CI working group of the last few months. Can you hear me all right? Is everything okay? Okay, great. So for the one, so you might know GitLab as a free and open source Git repository hosting. So a little bit like GitHub, but open source. And it is true, it is a free and open source Git repository hosting, but the main value of GitLab is really in the CI-loop infrastructure. So GitLab comes with a very powerful yet flexible and fully open infrastructure for running CI loops, and it's particularly well suited for open source projects. And in fact, it's been used by many, including QEMU, adopted QEMU upstream the GitLab CI infrastructure. So what makes the GitLab CI unique? It's the fact that it has no lock-in whatsoever. So this is the way it works. For each commit or other events, a CI loop is triggered, which GitLab calls a pipeline. A pipeline is just a series of build and test jobs. And if they all pass, the pipeline is green and everything is well. So the key to make this flexible and open is that a job, as we'll see in more details later, is just any container that you might define. And the runner, which is the entity that takes these jobs and executes them one at a time for testing, is also something that you can provide quite easily. Now, of course, GitLab provides runners on demand, and some of them are also free for open source projects, but you can use your own. And this is what we do in Xen Project. And the runner can be really anything from a Raspberry Pi 4 to a large Rackspace VM in the cloud. And we did use a Raspberry Pi on another open source project related to Xen called RunX. So this gives you an extreme amount of freedom because you select your own hosts to run the jobs. You set them up the way you want them, as long as they have a runner instance, which is the thing pulling down the jobs and executing them. And you define the jobs, the test and the build jobs in any way you like in your own repository using a YAML text file called .gitlab.ci. .yaml, and then you define what container you want to run and how to do tests and to do builds. So it's incredibly flexible and open. So what is the GitLab really gives you if all of this is the runners are things you provide, the jobs are things you define, what is the GitLab really provides? GitLab provides infrastructure. So the automatic way to trigger the job executions, the pipeline executions, give you a nice UI that you can use to monitor the pipeline in flight. You can monitor the results. You can retrieve the logs. All of these handling infrastructure around the jobs and the pipeline and the runners. Doug, please go ahead. Doug?
Yes, yeah. Sorry. Got beach ball of death for a moment there. So we have a number of runners set up to test, and right now our environments are based on ARM and x86, which makes sense for Xen. We have a fairly capable ARM setup that's sponsored by ARM and hosted by Equinix. A lot of RAM, a lot of CPU cores. So we run jobs in parallel, right now 10 on those, on a new Ubuntu environment. The assumption here right now is that we're always going to build on Ubuntu. In the future, we can look at containerizing other environments so that we can do different build environments. The goal of this CI loop and everything is to ensure that there is not one pristine build environment that can be used. For example, if somebody's on CentOS or if somebody's on Ubuntu or Debian, it will all build, it'll build the correct artifacts that'll build the correct results. We build, we're building on these. So the other part for x86, we have a bunch of Rackspace hosted VMs. And we kind of set this up in a dynamic fashion using this thing called Docker Machine. Docker Machine effectively allows you to have a Docker VM somewhere else that's just running Docker and spawn off the jobs there. And so we have this main runner that accepts all the jobs and then spins up build VMs. Initially, when we built this out a couple of years ago, we kind of scaled it to 2 vCPUs and 4 gigs of RAM is the environment that each build and environment gets. We wanted to not require that everybody had, a beefy machine. So we went on the smaller side, but that's something we could also look at in the future. And it's supposed to be reflective again of like developer environments, and that's why we have all the Docker containers on x86. And the advantage of the Docker containers as well is that if a job fails, and let's say a developer natively uses Debian, but it fails to build for some reason on OpenSUSE, they can use that Docker container locally without having to install an OS or build a VM. It's a one kind of longish command line argument, but they'll get a shell inside of that container that is the same build environment that the CI-loop used, and they can troubleshoot that locally on their box. Right now, Rackspace is providing 20 VMs and 40 vCPUs and 80 gigs of RAM, but I'll look to increase that in the future. We might do larger VMs and then more of them, but we'll kind of see what we need to do. Next slide, if you would. So I kind of briefly touched on Docker Machine there. It gives us the whole host effectively. It's just if you think about it, it's just you have, if you're on a Windows machine, this is how it used to work, or on a Mac. You create a Linux VM because Docker is very Linux based. And it basically shuttles all the commands over there. And so they built this out for using TCP plus SSL connections to do that. And that's how it used to work on Windows and on Mac. But we can leverage that and build extra VMs and generate that. And that's what Docker Machine does. It packages all that into a nice thing. You can do Docker Machine create, and you give it a name and it'll build that. And you can also have many of them, and it'll give you all the necessary connection settings so that your normal Docker command line client just works. And that's exactly what GitLab CI is leveraging. And that's actually how they run all their current public infrastructure for building GitLab CI loops. If you create a project on GitLab and just start compiling things in GitLab CI, it's going to be using Docker Machine. I believe their VMs are at DigitalOcean. They might have moved to Google Cloud, but you're basically getting this environment. And the goal is also to provide a secure environment so that somebody can't maliciously attack your build from another build, which is why they separate things out into VMs. And so in the report, if you ever look at everything, you'll see only one runner if you look at the settings on your project, but that runner can do parallel jobs, and that's exactly what we're kind of exploiting here. The downside of this approach is that Docker Machine has been deprecated by Docker. GitLab has forked it, and they are just doing maintenance fixes. And with the building of a VM and tearing down, it does add a little bit of overhead there. And so that's something that we'll consider maybe changing in the future. Stefano, if you want to take it away.
Yeah. What is a job? So we discussed about pipelines and jobs and runners, but let's go a little bit more into details. So a job is essentially a container you select. You can choose an upstream container like a Debian Unstable, Ubuntu, SUSE, anything, right? Or one of your own. You can build your own container, add your own packages, make changes, and then push it, and then use that as a base. Either way is a container of your choice running a script of your choice. It's just as simple as that. So you say, I want this container, Debian Unstable. I want to run my testscript.sh. If the script exits 0, it's a success. If it doesn't exit 0, it's a failure. So it's straightforward, and I don't think it could be any easier. So, you select your environment, you select the script to run, exit 0 is green, doesn't exit 0 is not green. This is also how we use it, obviously, for both build and tests, and I'm going to give you a little bit more details. But the other thing to understand is the jobs are organized in a pipeline, as I said, and the pipeline is organized in stages. So we use 2 stages, the build stage and the test stage. During the build stage, we run all the build jobs, and during the test stage, we run the test jobs, so testing Xen at runtime. So in terms of builds, we do whole lots of builds. So we have a very high number of builds. I'm going to give you a small overview later, but we cover many varieties of Debian, Ubuntu, CentOS, SUSE, Alpine Linux, and more. We have a high number of combination between rand config, def config, GCC, Xilinx, debug on, debug off, is extremely rich. Now, if the build jobs succeed, then the pipeline moves to the test phase. Now, this is important because even if a single build job fails, then the pipeline will stop and will not go further. For the test jobs, so we are inside a container, so we cannot possibly run Xen as a user space application in a straightforward way. So what we do is we use QEMU. We use QEMU both on x86 to emulate a full x86 environment and on ARM to emulate a full ARM environment, and then we run Xen inside. So our test job is a script that invokes QEMU and passes the right command line arguments to start Xen, and then captures the output and see if it went as far as booting DOM 0 or whatever the test needs to do specifically. Which is a bit different today between x86 and ARM. On x86, we have XTF tests that are, Andrew wrote. On ARM, we have a couple of tests, a DOM 0-less test and a normal DOM 0 plus DOM U test. In the future, we have a number of test jobs that we want to run. Doug, you want to add some details on the future jobs that you had in mind?
Sure. So, it's no secret that Rackspace runs Xen. And so one of the things that we could do is try to boot the Xen hypervisor that we build nested on VMs. That would be outside of Docker, right? And we would boot there. And that's a kind of a question to the community. I'm not sure as to the value, because we could not control the L0 Xen. We would only control the nested Xen. So another idea was to just build those Xen artifacts and boot them on bare metal x86 hosts, and have some control there. And that would also be available as well. And so that's kind of a question out for the community of jobs that we could do. And we'd certainly love to see ideas around what we would test and how we would test that. But I'm more than happy to make sure that the hardware gets donated.
All right. Okay, thank you, Doug. Moving forward, how we use it. So we discussed what GitLab CI can do with its jobs, pipelines executed by runners. What do we do in Xen Project really with GitLab? So as you all know, the official Xen Project repository is on Xenbits. But we do have a mirror on GitLab as the URL on the slide, which is gitlab.com Xen Project Xen. That is mirroring all branches. So on new staging commits on the staging branch, a new pipeline is triggered. Pipeline that execute the build jobs I described before. Most of them are required, so there is a flag on the jobs that can say a job is allowed failure. Currently, we have 4 jobs that are allowed failure, that are SUSE tumbleweed jobs, but all the others are required. After that, we move to the test stage where we run the 3 or 4 XTF tests that we have, and the 2 ARM tests, DOM zeroless and DOM user we have. And if they succeed, the pipeline is green. Now, this is all good, but by the time we reach staging, in a way, it's already too late, right? Because GitLab CI is not blocking. It's not a replacement for OSS test and is not meant to be. So by the time a commit reaches staging, yes, we can flag that something went wrong, but the commit is in staging, right? It's going to remain in staging. So what we really want is a way to stop the commit, the broken commit, to actually be committed, right? So we will want the CI loop to tell us beforehand. And this is where PACHU come in. Pham, are you with us? Do you want to say a few words, or should I cover it? I don't see Pham among the attendee lists. Okay, speak if you are up. I'm more than happy. So Pham is the one that actually did the work here. Pham Deng. So he contributed the PACHU instance that we're currently using. So PACHU is an open source project as maintained by Pham and Paolo Bonzini. The source is hosted on GitHub and is actively used by QEMU and now by us as well. So what is the PACHU does? So PACHU is a tool that scans a mailing list for patch series, identifies a patch series, and then commits it to a branch. What it does is really scan Xen-devel in our case, identifies patch series on Xen-devel, and then it uses git am and git push to commit those patches to a PACHU repository that then in turn triggers the pipeline. Again, the patches are applied against staging. A new tag appear on. This is the URL for PACHU, slightly different. So GitLab.com Xen Project PACHU Xen as his own mirror, and new branches are created, and GitLab CI job gets triggered automatically. Right, that's the important bit. The other important bit is that PACHU, in case of failures or pipeline failures, is also able to send emails back. So it's gonna, you might have seen a couple on the mailing list already. So far, we have not enabled sending PACHU results back to the mailing list in general. I mean, for all PACHU pipelines, only a few times. But is one of the things that we're looking forward to do, because this way we can automatically notify the contributor or the maintainer or both that a pipeline failed and why. Hi, Doug?
Sorry, every time I turn my camera on, it kind of hangs for a second. So right now, maintainers are able to, and anybody that's a member of the Xen project on GitLab is able to create a repository nested under the Xen project. In this kind of syntax here, the Xen project /people, and then your name that you go by. anytime you do any pushes to your branch or a branch there, or create a branch or whatnot, it will use the existing defined pipeline in that GitLab CI YAML that Stefano mentioned, and it will run all the existing tests that we have. So you can develop additions to tests as well, and it'll run those tests. There's currently no restrictions. The only restriction is that you have to be a member of the Xen project. That's kind of how we're gating that. So any maintainers of any component are more than welcome. We'll add you, and certainly if the community wants to add other folks that are stepping up to be a maintainer of something, we can add you as well. There's no restrictions there. So earlier I had mentioned that if you worked on a different distro than where the failure was happening, how you can drop into those environments. And we try to make a bunch of scripts to kind of make it a little easier. It'll never be, as seamless as just running make. There's a little bit of environment changes. So we've got this script that is from the top level of Xen.git. You've got /automation/scripts /containerize. And containerize does a whole lot of needful behind the scenes for you. It's effectively going to mount your top level Xen.git tree inside of the container as a read-write mount, so that you can make any changes in there. The build succeeds, and yeah. So it also supports taking command line arguments so that you don't have to drop out of your own shell and into the very limited bash shell that's in there. So you can pass parameters. So for example, you can say make, you can say any arguments you want there. There is a default container, and I forget what the default container is, but it can be controlled through an environment variable that we've called container. There's a lot of containers that are available today. I kind of listed those out on the slide, but any of the popular environments we want to have a container for. Any of the environments we expect users or developers to build on, we want to have an environment for. There are a number of known issues with the CI loop today, and so we need to kind of dig into those. Ran config is kind of one of the bigger known ones, because we basically just ran config. If you're familiar with the kernel build, we generate a random kconfig for the hypervisor and try to build with that and go with that. And so that uncovers issues. We need to rebuild the containers automatically, periodically, because they tend to get stale and people upgrade their development environments. But if the container is, a year old or so, it doesn't reflect that. We're going to do some work there and improve that. We also have some issues on the git clone on x86, and it's the best we've been able to troubleshoot it. It's that the VMs that we're doing builds in are ephemeral, and they get different outbound IPs. And it seems like there's one IP that we'll get every now and then that is firewalled somewhere along the way to one of the repos that Xen's own build system clones down internally. And so one of the ideas has been to switch to a static pool of runners rather than building them up and tearing them down. So they're always there, and we know the state of them. And then we're cloning down a lot of info. A lot of these, QEMU is a long repo, and so it takes quite a bit of time to clone that down. So maybe doing shallow clones and whatnot in those would improve it.
Okay. Next step, so we obviously want to increase the number of tests, address the known issue we just discussed. One of the problems is also that PACHU, when it sees an allowed failure, it thinks the failure of the pipeline, which is one of the things we need to address, while allowed failure are in fact allowed. But ideally, really, we want to be able to make the GitLab CI more part of the regular workflow so that maintainers will always look at GitLab CI before committing. And makes sense because if GitLab CI break, it's probably because they commit. There is an error in the commit itself that we want to present. So I wanted to spend the last couple of minutes to give you an overview. So this is a pipeline that passed. As you can see, is all green. There is a high number of, as you can see, build jobs and just a few test jobs. So the build jobs are the one I was mentioning, building, for instance, I don't know, GCC on CentOS, or this is Debian Jessie 32-bit Xilinx debug, just to pick one at random. And if you click on one, you can see all the logs of the build that is succeeding. You can also see a raw version of the full logs, like the complete log. So for debugging, this is very helpful. Not much this time, given that it passed. And you can also browse any artifacts. These are the binary artifacts output of the build that have been used for testing or for the build itself. So if I browse here, I can see some build logs and also the configuration for Xen, particularly useful for run config failure. In fact, I wanted to give you an example. This is another pipeline from a week ago with the run config failure. And you can see the run config failure. First of all, test has not been run, right? Because at least one build failed. So if we scan through the jobs, it's all green, and bam, there is one red here. And if we continue down, it's all green. These are the 4 OpenSUSE allowed to fail jobs. They are yellow, as you can see, different color. We continue down and they're all green. So already the fact that only one job failed, and let's look at which job it is run config failure. It says the name, right? Debian unstable run config. So this full name is also here. GCC ARM32 debug run config. So obviously this is caused by run config, right? I also wanted to show you an example of a genuine failure. So this is a genuine failure. Again, the test didn't even get executed because one or more build jobs failed. And you can see here, there is a number of build jobs that failed. 2 Alpine Linux, 4 Debian. And if you go and look, you'll see that they are all Xilinx. All of these jobs are Xilinx. And in fact, this was a breakage of the Xilinx build. And if you go and look at the logs in details, you can even check what they are exactly. And I recommend you click on this button to get the full raw log so that you can then even download to your machine, use VI or Emacs or anything you would like to scan through the logs. I know I'm out of time, so I'm going to maybe take one question if you have it. And then, of course, we will be happy to continue on mailing list or other forums. I see somebody's typing. Yeah, definitely. We are also open to do a design session if there is interest, and I will to discuss this more into details also, with you guys and maintainers and everybody in the community. Thank you all.